Yeah, so I'm recording now for the internet, so let's not talk like that anymore. All right, number 12 in the notes. So we're on global change, remember, and number 12 starts this section called global climate change. Ooh, and what are two of our main big causes? What's one of our indicators of climate change? An increase in temperature. That's good. What do we think primarily attributes to the temperature increase?
Greenhouse gas.
CO2, one of them, and the other greenhouse gases. So if you guys will turn to 530 and 531 in your book, we'll have some kind of reference points here. And the increase in CO2 levels is primarily due to two things. What are they? Yeah, so burning fossil fuels, okay, like cars. And then also what else is attributed to causes the increase in CO2? Cutting down trees. So if you're cutting down massive amounts of forest vegetation, those forests aren't going to be able to what?
Photosynthesis.
Take in CO2 through photosynthesis. Good. So those are two main reasons that we see this increase in CO2. Now, in your book here on 530, we can see that there's pretty dramatic fluctuations in CO2 levels over time, but we also see a consistent pattern from about 180 parts per million up to about 280 parts per million. Now, your book's a little old, but in 2010, that CO2 level gets up to about what?
About 375.
375,
380. Probably.
Let's say 380. I thought it said we're up close to. It says 390 there. I don't know. That graph's not all the way to 390. So roughly about 390 during that point in time, and I imagine since then it's probably increased a little bit more. So we see this dramatic fluctuation outside of what the norm is. Now, one thing that we really need to talk about here, because we said the main controversy about climate change or global warming is well, some people say it doesn't exist, but for most all scientists that have looked at the data, the temperature has increased slightly, about a degree in the last century plus, maybe a little bit more, degree Fahrenheit. And so, what's the other thing?
Some people think that it's just like a natural occurrence.
Yeah, and so if you look here and on 531, you'll notice that they have CO2 levels and also temperature levels. And those have changed over the past 400,000 years or so. So we see a continuous temperature fluctuation. So here's our temperature fluctuation and CO2 fluctuation on one graph. Now, I know what you're thinking. How in the world do they know what the temperature was 400,000 years ago? Who knows?
Organisms?
Jesus.
How do we know?
That's a good answer.
We'll talk about that on Thursday. We'll talk about that on Thursday. So, how did they know what organisms were around a long time ago? Fossils. So, the deeper down you go, the older the fossils, right? So, is there any way that we know what was in the air 400,000 years ago? Can't really look in the rocks because they weren't put down at a consistent rate. What? Let's turn back to 529.
The difference in the fossils and like how they were buried over time.
Ice cores.
Ooh, ice cores. And so basically what happens with ice cores is they have somebody, you may have seen that movie Day After Tomorrow. It's a little fanciful, but anyway, they talk about ice cores and they're looking for data and then the whole world freezes over. But anyway, the ice cores. Basically what's happening here, Rachel, is they're digging down, they're taking this core of ice out. Now if you just think about like snow falling. So you have snow falling, these light little snowflakes, they land, and then there's some more and some more and some more. And so somewhere like Antarctica, these snowflakes continue to cover up and bury. And then when there's enough of them, they get compressed. But as those light little fluffy snowflakes fall, they're trapping what in them? Air, little bubbles of air. And so over time, they build up and build up and build up. And those little bubbles of air are like a window into what the past atmosphere looked like. And so you could see like maybe volcanic ash in some of those. But you can also detect CO2 levels. And then the one thing that they primarily look at for temperature is what? Nope. On 530 at the top, I'm not going to get into it right now. We may go back and read through this, but they look at isotopes of oxygen. And so apparently there's one like heavy isotope of oxygen 18, and this is indicative of warmer temperature periods. And so they're looking at the amounts of these isotopes. Is it much lower? Is it much higher? And that's an indicator of temperature during that time period. Okay? So CO2 levels, like you said, Jordan, also play into that because we can see the CO2 levels and temperature on 531 is almost hand in hand. And you can think of, well, CO2 levels and O2 levels are going to go together as well, right? Because you got, when CO2 levels go up, then you got a lot of CO2, oxygen is going to get produced. So those are going to go hand in hand during those time periods. Now, we see these natural fluctuations. So is it possible that we have a natural temperature fluctuation now? Yes. Most scientists would argue that the temperature fluctuation we see over the past 100 years or so, though it's very rapid, and it's pretty obvious to see that there's an increase in greenhouse gases. There's also what more am I looking for? A gigantic jump in the amount of just think about all the cities and roads we have where you have concrete and asphalt that's absorbing heat. We have a lot more heat absorbing substances on Earth now than we did in the past. There's less trees, which help to shade and kind of cool things. And so there's just a lot more things that are holding heat in as well. Okay. And so that's indicative of it's more of a human caused problem and something that we want to work on and hopefully mitigate in the future. So number 12, the Earth has undergone climate change throughout geologic time. So that's something we know for sure, with major shifts in global temperatures causing periods of warming and cooling as recorded by CO2 data and ice cores. And also, like I said, looking at the oxygen isotopes there is very important as well. So we know these natural fluctuations in climate change happen. We had an ice age not that long ago. Was it 12,000 years ago the last ice age ended? And so not that long ago, it was really cold, and there weren't that many people around, so that didn't cause the end of the last ice age. So some of these natural fluctuations in climate occurred at that point in time. But are we seeing a dramatic increase in temperature now? And if so, do we have evidence that humans are causing it? Okay. Number 13.
Wait, what was it called?
What?
What was it called again?
12. The Earth has undergone climate change throughout geologic time, with major shifts in global temperatures causing periods of warming and cooling as recorded with CO2 data and ice cores. Good. All right, any questions there? All right, number 12. The effects of climate change include rising temperatures. Okay, so that's one of our big things and why it's originally we referred to it as global warming. And then include rising temperatures, which lead to, they didn't really put it in here like this, melting permafrost and sea ice. Now, we've talked a lot about sea ice, like, for instance, in the Arctic Ocean, which is like where the North Pole is. Did y'all know the North Pole is not really like land, it's just ocean there? Okay, so, man, what was it? I think it was the Russians. They sent a submarine up there and like planted a little flag in the North Pole under the ice, if I'm not mistaken, one time. Watch out, you people.
They all submerged.
Trying to claim it. Did y'all hear that China and Russia was talking about doing like a tag team base on the moon? Did y'all hear about that?
What?
They were thinking about building a base on the moon for to mine minerals and whatnot. Communists. Anyway, so
This is the internet. That's what you're saying.
The communists are listening to you.
You don't
that's
know.
probably true. I think they're more worried about our elections than my lectures. Anyway, so
They can probably pick up on you saying communist.
you think they can pick up on me saying that?
What minerals are they looking for?
Hey, I think if you're there, communist isn't a bad word like it is in America.
Yeah,
It's probably a compliment.
It probably is.
Hold on a second. What?
I said McCarthyism. That's all I know about communism.
Okay, effects of climate change include rising temperatures. Oh, melting permafrost before I got on that tangent. So, melting permafrost. How do we have any evidence of that occurring current day?
Yeah.
What?
It's the caribou, yeah. And the mosquitoes.
In
Because there's
Russia.
so much water.
Well, we talked about that. What's going on in Russia? Speaking of the Russians.
Permafrost is melting and they're worried about diseases and stuff getting out.
Yeah, so I don't know if you've seen any stuff lately in the news about like them finding a lot of ice age animals. And so
Really?
you have a lot of permafrost that's melting over there in Siberia in the summertime. This stuff's been frozen for thousands of years since the last ice age, and now it's starting to melt. And so, like, imagine along a riverbank, the permafrost starts to melt. You have rivers that flow through there in the spring as the ice melts. And then you have like a baby mammoth be exposed, or like a dire wolf, or anything you can think of.
What
From
if they wake up?
yeah, they're not going to wet. They're dead, but they're.
Have they found
The
any-
problem that Colby was referring to is, let's say that one of these animals has a bacteria or virus or something that may have killed it or may have just been on it, and then like that joker starts thawing out, and so you still have skin and meat. So a scavenger comes along, it eats on it, and then it gets that bacteria and virus that's been buried for thousands of years, and then it starts
Everyone
to
dies.
then yeah, stuff starts dying. So
Have they found that guy that looks like Demar?
which guy?
The little animal on Ice Age?
You that's not very nice. I'm gonna make you apologize to him during seventh period.
I'm
Just
not
because
apologizing to him.
just because he knocked over your coffee doesn't mean you can.
Are you talking about a sloth?
Yeah.
See it.
Is he a sloth? Is he a sloth?
Yeah, he's a sloth. He's
It's
a,
not
he's
sitting
a
a
sloth.
sloth.
He don't look like
Now, for clarification on sloths,
He does look like Demar.
sloths back in the day were like bears nowadays. Those sloths were different. They weren't like climbing up a tree and slow and
Yeah, that's
not like the one on Ice Age, the movie.
Yeah, that's what I'm saying.
They were like huge. They
He
were,
doesn't look like a sloth.
It looks like a big.
stop talking about people on the internet.
I wasn't talking about Demar.
All right.
I'm talking about Sid.
You talking about the
Sid doesn't
Russians
look
and
like
their
Rachel,
communism.
you're gonna have to tell the office over this.
No.
Okay,
Come on, dude.
Wait, what?
That's an
I
interesting
like
thing.
your income.
What was that?
That's my keys. Those my keys. Yeah, I can't read my phone.
okay. So, number 13. Melting permafrost and sea ice. So anyway, there's a lot of stuff melting, and I'm gonna write this down on my things to things to show y'all. I'll see if I can find some melting permafrost with some of these ice age animals, just so I give you a little context. And that's always interesting. I always thought it'd be cool to go over there and look for stuff that's like thawing out, but apparently there's a lot of Russians running up and down the rivers and running around trying to find stuff so that they can. I mean, that stuff's like big money.
But
You-
that's scary though. They're gonna like get diseases from it and then spread it around.
Maybe. I mean, I don't know. Like when they get, I do know this, Sophie. When they went back and they tried to, I think it was some Japanese scientists tried to clone a woolly mammoth. They said the DNA, like so, the DNA, those molecules kind of break down,
Yeah.
and they could only get about 70% of the DNA they needed, and then the rest they were going to have to like supplement with DNA from like an Asiatic elephant. So it would really be kind of like a cross if they were able to actually merge some of that DNA. So some of that DNA does break down. I guess the hope would be like bacteria and viruses, like the DNA breaks down enough where it's not transmittable.
Did they
But-
clone anything else besides that sheep?
Probably.
We should clone Abraham Lincoln.
Have they cloned anything else?
I haven't.
Yeah. I mean, you could get like your cat and dog clone, I think, for about 50 grand there for one
Yeah,
time.
but like I'm saying, anything like cool.
It wouldn't be the same.
Anything cool?
You never did like the report cards.
Miss Mara already came by and got him.
I want to clone my dog.
Okay, thank you.
You walked me into a wrong conversation.
They're amazing. She just
What would
sits
you
there.
What would you do if you like actually saw like a woolly mammoth or another ice age animal? Like
If I saw like walking around,
Yes.
I think of-
If
well,
you saw
woolly
a
mammoths are
dinosaur
huge.
walking
Woolly
around,
mammoth,
what would you do?
Yeah, or
that's pretty big. I mean,
If you saw a dinosaur like that'd be so weird.
for real. What would we do?
if you saw a dinosaur, it would be weird.
It
Yes.
would crush everything.
Like,
I mean, it'd just be like a big elephant, right?
But elephants are already big.
But Jurassic Park, they're probably like faster than elephants.
Okay, so
Answer the question.
number, I don't know what I would do. I've not given it a lot of consideration because it's never going to happen.
What if you saw an alien?
I'm gonna make it happen.
Melting permafrost, melting sea ice, rising sea levels due to all that stuff. So we talked about that. Now the rising sea levels are fairly small at this point. Part of that rising sea level, remember, is due to the melting ice, and some of it's due to thermal expansion of the oceans as they get warmer. And then also, a big problem associated with this is displacement of coastal populations. So we said this is primarily going to affect in like this century. is going to affect people living in low-lying coastal communities. So like people in like tribal people on a small island out in the middle of the Pacific somewhere that's only, 4 or 5 feet above sea level at its highest point. So these are the people that are going to bear the brunt of this first. People, that have basically no contribution to increased greenhouse gases in the atmosphere. Okay? And then number 14. Let's move on here. Marine ecosystems are affected by changes in sea level, some positively, such as in newly created habitats on now flooded continental shelves. So basically, they're saying, like, as the sea level rises, it's going to provide new habitat that they wouldn't have access to previously. But the other issue is some negative side effects for those marine ecosystems as the communities are going to get deeper and deeper down. So for instance, let's say you're a photosynthesizer with that absorbs a certain wavelength, Andrew, of light. In the sea, there are different colors. We talked about the different colors. I think it's, what is it? Red light goes just a little ways, and then you have like blue, Roy G. Biv, blue and violet, and that whole section there. The different the different wavelengths there, because of their wavelength, I think it's going to go much deeper, and so you're going to wind up with different photosynthesizers at different levels based on their ability to absorb those wavelengths of light. And if you deepen the level of the ocean, then it's going to change where they can live. Or even imagine like a coral reef. Like most coral reefs are in pretty shallow water, so you fluctuate the sea level, then you're going to fluctuate where those organisms can live and how well they can do. All right. Yes, some negatively affected by, such as deeper communities that may no longer live in the photic zone of seawater. I kind of elaborated a little bit on that, but basically it's fluctuating where the light can be absorbed. All right, and the last thing before we watch a video and hopefully not get on another tangent is number 15. So, number 15 is a discussion of winds generated by atmospheric circulation help transport heat throughout the earth. So, just like we have fronts that move through here constantly bringing cold air, warm air, these winds and atmospheric circulation, they're moving stuff all over the world. So we see these increases in temperature. We talked about it with the ozone and the ozone layer. We see this movement of particles. That's why really no matter where you go in the world, you would expect to see the same level of CO2, O2, the constituents of the air should be the same. Even if you've got a lot of photosynthesizing going on in your place, it's getting moved around, okay? So we don't see huge fluctuations. All right, climate change may change circulation patterns. So this is another thing that was brought up in that movie, what was it, Day After Tomorrow? Did y'all see that?
No.
It's not a very good scientific movie, but, I mean, the greater point of we don't know the effects of increased temperatures. So one of the things brought about in the movie was there was increased melting of Arctic sea ice. And that Arctic sea ice from up there, like around Greenland, poured into the North Atlantic. And so there's this thing called the North Atlantic oscillation where you have these currents that come up and they're moving water around. And so basically what their contention was, and I've heard other people say this may actually happen, just not on that scale, is that if you pour enough cold water, like cold fresh water, into that northern part of the Atlantic where it's it's seawater and it's a little bit warmer, because a lot of that water is coming up out of the Gulf, then you're going to affect that whole movement in ocean currents in the Atlantic Ocean. And so how does it affect other places if you stop those ocean currents? So that's something that we really just don't know the large scale effects of, okay? It may also impact Hadley cells. Remember, Hadley cells are where moisture comes up at the equator, it rains back down, and then that drier air gets pushed out away from the equator, which causes most of our deserts at about 20 or 30 degrees latitude. And then may also affect the jet stream. And if you ever listen to your weather person, they talk about the jet stream a lot, because the jet stream kind of dips down, it goes up, and that brings us a lot of the weather that we encounter throughout the year. So a bigger worry than just I don't know if a bigger worry, also a very important issue besides a temperature increase is, what are the impacts on all these different systems throughout the world that affect our weather and affect our climate? Okay, and that's kind of how we went from global warming to climate change, because there's a lot more going on than just an increase in temperature. Okay? Good hustle.